Right. So welcome everyone. Thanks for joining also with all the technical issues we had. We would like to try something new today in this session. We came up with basically like somewhat like a case study, which we would like to discuss with you guys how you could work on those kind of mutations when you see them in your lab, what you could do. So how shall we do it? So it's, I sent in the email, it's a combination of a BRAF and KIT mutation in gastric tumors. And Beth created a couple of slides of background on those two mutations. I'll present the case we have, and then we can, we would love to have your input anytime in between. So we don't want to have a full presentation here today.
Right. Yeah, it's meant to be more of a discussion on how we would look at these variants and things that we might want to consider when we see, interacting variants or variants that might have a compound effect. So, do you want to present the case and then we can kind of backpedal and do some
Oh yeah, okay. We can also do that. Yeah. So let's I'm sorry, I'll thought I would do that in that case. Yeah. So we had a patient with a gastrointestinal stroma tumor, GIST, and two mutations, one in KIT and one in BRAF. And actually, if we would just have known that, that would have been puzzling in the first place. But in addition to that, he was diagnosed with a B-cell chronic lymphocytic leukemia 3 years before that. And what you see here is that we had discordant variant allele frequencies, which suggested that we had a mixture in the sample of the KIT, which is sample 1, versus the CLL sample. But basically what we started with was this information on sample 1. So, yeah. And so we had two things to consider. First of all, two different tumor entities, which we weren't sure at that moment how to deal with that. And we had allele frequencies, which were discordant in the first sample, and we weren't sure whether this was due to subclonal types or really different types of like the two tumors.
Collision tumor kind of deal. So sample 1, so sample 1 was that the CLL?
No, the sample 1 was from the GIST. And,
okay, great.
Yeah, and then we took a second, we found a second sample, which was really just from the CLL. And here we could verify that we actually had the same BRAF mutations. And why is that puzzling in the first place? If we look at the, and maybe also if we look at studies in CBioPortal, 2MSK studies, you actually don't see any BRAF mutations in GIST. I think it was 3 patients who have a BRAF V600E mutation, but no other mutation in BRAF. So it's really just a class 1 mutation in there, whereas you have the second mutation in KIT 599. That's actually the one with the second highest prevalence in GIST and quite often happening. So it's actually a mutual exclusivity in that respect, that we don't have any mutations in BRAF if we have a mutation in KIT. Yeah, but maybe you can like give some background on the mutations itself. So
yeah, so many of you probably are aware that BRAF mutations come in a couple different flavors. So we have class 1 mutations, which are V600 mutations, class 2 mutations, which are RAS independent active dimers, and then class 3 mutations, which are RAS dependent. And so through this study that I've cited here in biomarker research, they found that this was basically on colorectal cancers. So CRC tumors with class 2 and 3 BRAF mutations had less unique genetic profiles than V600. And class 3 had the best survival outcomes regardless of treatment strategy. So kind of interesting here, but the variant in question here is in the red box in class 2. And so these are RAS independent active dimers. So this mutation will activate BRAF and act as an oncogenic mutation. So I wanted to show kind of the RAS pathway interactions with BRAF to show how these things work. And so you can see in class 1, it's RAS independent. You have your BRAF mutation and it goes ahead and activates MEK and ERK and all of your downstream targets from there. Class 2 is kinase activated. So often you need to have a couple different alleles that are mutated, but not necessarily. And then you can activate your downstream pathways as well. And then class 3, kinase is impaired. So you're dependent on RAS and some heterodimers with BRAF. And so with class 2, you're looking for your BRAF, like a homodimer, so BRAF dimers to come together, 2 molecules. With class 3, you're looking for help from another RAF entity. So yeah, this is kind of in a nutshell some of the pathogenic flavors of BRAF. So yeah, you can go forward. And then I wanted to also touch on activating KIT mutations in gastric tumors. These are super common, often seen as in-frame deletions in KIT. With exons 9 and exon 11 being the most common. And exon 11 alterations, such as the one in our case, which is the 559D, are really common in GIST. Imatinib is FDA approved to treat patients with KIT overexpression and activation. And that gets targets KIT directly. And there are also clinical trials for resistance reversal strategies using heat shock proteins. So we have a little bit of evidence that those might be promising moving forward. Overall, these variants are associated with good response rates and overall survival compared with KIT exon 9 variants and also compared to KIT wild type GIST. Yeah, so pretty much we have our BRAF mutation, which is class 2, RAS independent, reliant on dimerization of BRAF to drive oncogenesis. And then we also have these KIT mutations, which are activating and actionable. But there's a catch, which we can take a look at the next slide.
Okay, yeah.
So yeah, you can go ahead and I'll pass it to you.
Yeah, so thanks for the overview. And as said, we had now two things to look for, the diagnostic challenge. And here the question is, we were lucky that we had additional material. But one question would be, is it possible to identify this blood tumor and basically mixture in the sample with different techniques than doing through NGS analysis. And the second question is, so if we have interactions like this, BRAF could actually be a source of primary resistance to imatinib. And then, I mean, we have to treat the patient somewhat, and we started with imatinib, but had to find a way to continue then with this additional information on a second tumor. So we would like to open up the discussion here on, first of all, diagnostic approaches, but also on, like, how would you discuss it in your tumor board? What kind of therapeutic implications would you take into consideration?
So I have one question. Did you look into like leukocyte infiltration of the gastric tumor at all, like through pathology?
So we did histopathology on the gastric tumor, and I do have the histology information. Let me just see what I can open that up. I have to admit though, I'm not very good at reading this. The question is it already shared? Is that part shared as well now? Can you see this, the histology? Or should I? Yeah,
I
okay.
can see it.
Okay, great. I wasn't sure whether I was sharing the full screen or just the presentation. So we do have some stainings on
H&E. And the H&Es look very different to me.
Okay,
For the CLL, you have the big dark nuclei, round nuclei, which are leukocytes, whereas the GIST, either you have like your cells kind of being smushed, or you have a more like spindly appearance there. And that's my like very rudimentary analysis of this. So if there's anybody who's more well versed in pathology, you can jump in. But yeah, we know that leukocytes are typically round, so this is probably the CLL is likely taken from a lymph node. This doesn't look like it's in suspension. So yeah, there's the lymph node on the left.
Let me check. So that's gastric biopsy. Yeah, so that's
okay.
So
oh, they're noting CLL infiltrates. Yeah.
Yeah. So the question is,
that's within the gastric biopsy. Yeah.
Yeah. Yeah. So we have the CLL on top and we have the GIST on low. But the question is, I mean, I wouldn't be able to spot those. And the question is that enough to identify and say that we actually should look out for variants which belong to both? I mean, usually if you take a biopsy and then do panel sequencing on the bulk, I would say,
okay.
Yeah. So I would say that in principle, you have to have a lot of infiltrates to actually overshadow the allele frequencies of the actual tumor, of the GIST. And based on the HE staining, I wouldn't say that the infiltration is that large. If I assume that the dark spots are the infiltration.
Yeah, the infiltrating leukocytes are actually annotated by the arrows in the H&E.
Yeah.
So you see the round nuclei there. Those are your infiltrates. And I don't know, maybe, I mean, yeah, you could have a lot of leukocyte infiltration, but also there's been a lot of study on tumor microenvironment. So like can the CLL cells like influence the gastric tumor in any way? I don't know.
But if you're, yeah, but if you're
Not.
talking tumor microenvironment, then you would have to do a RNA expression.
Yeah.
I don't know. What would be your take on that? We do have a couple of panels for that, and otherwise it would be whole transcriptome analysis. Is that
Yeah.
how would you go for that?
I almost
Were
wonder.
these the only two mutations detected at all in both of the?
No, I think there were a few more, but these were the ones which were then relevant for treatment. Yeah, that's a good
Yeah.
point. Yeah.
Just in terms of like whether the source of the BRAF mutation is the CLL or if it was part of the GIST tumor would inform, treatment of the GIST, right?
Yes, but we didn't find, if we go back to, so did find it in the CLL in the same, exactly the same position. So that's why the assumption was that this is actually really coming from the CLL.
Right, right.
Also, if you look into CLL, so first of all, I said in GIST there's hardly any BRAF mutation described, and the other way around, if you look into CLL, they have basically a mutual exclusivity between KIT and BRAF as well, but the other way around. So I did prepare one. And I mean, this is something I prepared for today, so it's statistically not exactly sound. So it's I went into cBioPortal and tried to find all the studies either related to GIST or to CLL, and looked just for KIT and BRAF mutations, independent of where they're located.
I
And
went through our experience too, and I did not find any BRAF and KIT co-mutants in the samples that I looked into. I'm sure there are more ways for me to search thousands and thousands of samples here, but I didn't find any. So that supports mutual exclusivity.
yeah, and the same here, you see that.
And I have a question. Since the CL is usually patient have lymphocytosis and easy to get peripheral blood to get, test CL genome, did you do that NGS on the peripheral blood, for example, to see the allele frequency for the BRAF or KIT? This is the one. Second thing is the CL usually have the recurrent copy number aberrations comparing to just a tumor. So they will have specific, say, 13q deletion, maybe plus 12 or maybe 53 deletion or ATM something. So I'm wondering if it's accessible for you to get a CL genome just to do a copy number and also an NGS to see the allele frequency comparing with this tissue from a GIST tumor with a combination of the BRAF and KIT.
Copy number changes. No, we didn't look for those, and we didn't do a whole genome analysis. And at that time point, we also didn't have a panel which was covering copy number changes. Is that what you were suggesting?
Well, I was thinking, but because usually in the CL patients are in our laboratories come with the peripheral blood if there is lymphocytosis, for example, and it's easy to detect the recurrent mutations and also the recurrent aberration in the CL. Then if you see, say, from peripheral blood, if there is involvement, if you see BRAF and a KIT with higher frequency, for example, then most likely that these aberrations would belong to the CL, not only belong to the tumor of GIST, right? So, or vice versa. So if these mutations are not with very low frequency or maybe zero frequency in the CL genome, then this could be just only.
Yeah, no, that's no, we didn't do that. I mean, I was wondering with now spatial transcriptomics whether it would have made spatial analysis, whether it would have made sense to actually go for that and see the infiltration really like on the histology slides, basically
Yeah.
see an overexpression.
Like, is it like localized just to those
Yeah.
infiltrating leukocytes, or is it also within the gist, within the gastric epithelial cells or stromal cells? So, wow, cool case. I didn't look at these slides at all. So, yeah, this is really cool. So, I guess
Can I
my
ask?
next oh yeah, go
Oh,
ahead,
sorry.
please.
So if you had a way to determine that the BRAF was coming from the CLL and the kit obviously is coming from the GIST, would you be inclined to treat with imatinib? Because the BRAF is, if it's in a different cell, it's unlikely to be causing resistance, right? So if the GIST is the more clinically relevant tumor at that moment, would you treat with imatinib to try to bang back the GIST and then worry about the CLL?
Yeah, so we actually did treat with imatinib, and that also helped reduce the GIST. And then, so he had a CLL progression. So we had basically to worry about treatment of two different tumor entities at the same time, rather than working with the resistance and looking at toxicity between combination therapies, which are probably not made for any combination in the first place,
Right.
because you usually don't have to worry about that. So yeah. Yeah, so we had to worry about that. And the CLL was then additionally treated with sanucotinib, but with a reduced dose, in addition to imatinib. And yeah, so the leukocytosis resolved, and it was quite well tolerated. So now also the tumor, as the tumor is reduced in size, they're now working and planning the surgery actually of the patient and removing the GIST.
That's cool. So was the treatment regimen like the cadence of it altered, or was it more so, I mean, you said it was a combination therapy, but was it like you get one round of like imatinib and then another round of the CLL the BRAF inhibitor, or like how did that work? You just
yeah,
like
I think
altered.
I think let me check. Maybe Damian is on the call, but I think it was in addition. So it wasn't like alterating, but really in addition. So he only had to go once.
Okay. Yeah, that's really interesting because like technically it's a combination therapy, but they're targeting two separate populations. So maybe they act more like a single therapy for each tumor. The only thing that I would think about too would be like toxicity for the patient.
Yeah.
How does
But
that?
yeah. The toxicity, I totally agree on the toxicity, but if you have two clonal subpopulations of the same tumor and would give a combination therapy, wouldn't that be the same then? That you basically have two single treatments to different
Yeah,
subtypes?
right. But it's still like that cocktail that you're giving to a patient and you're not quite sure what it will do, but no, it sounds, yeah. I mean, I'm not a clinician and I'm not like super well versed with like therapeutic regimens, so I'm just asking to learn.
Yeah, from a molecular standpoint, at least you don't have to worry about the BRAF causing resistance to the imatinib in the GIST tumor. That you think, it's if that really isn't a different cell, which it seems like it is, the different cell population, at least the imatinib should be effective.
Yes, and it seems like it is. So that's for sure. It was really interesting to see, like, how often do you have this kind of cases where you have actually two different tumor entities to consider?
Was the CLL was diagnosed first and was pre-treated?
Yeah, it was so he was diagnosed 3 years earlier with CLL, and I think he didn't, let me check.
I don't know how often a GIST is a secondary tumor. That seems unusual, but
yeah, it was also first version that I saw that.
Well, isn't CLL, maybe I'm completely wrong, but isn't CLL kind of like a slow progressing disease?
Yeah.
So that could be something that goes like undiagnosed for a while. Something triggers the GIST to start, and they're just two completely different events.
yeah.
Then you have the lymph nodes that are near your stomach, and that confounds your results.
Actually, yes. I mean, you can go for 20 years without having any need for treatment. So it would be interesting to know, like, whether maybe the GIST treatment actually triggered something in the CLL tumor, because apparently it flamed up, in, if I can say it like that, after the treatment.
That's interesting because the pathways are somewhat connected. If BRAF causes resistance to KIT inhibition, then KIT inhibition, I don't know, I'd have to draw
Well,
it out.
imatinib is dirty too. Imatinib doesn't just target KIT, so
yeah,
that you're gonna. It's entirely possible that treating with imatinib could have, whether it's even just
right.
immune suppression, right?
Yeah.
That you could end up having the CLL flare because of it.
That's an interesting concept. So is it a pathway manipulation that caused over the CLL progression, or is it just the immunosuppression itself? That's a cool question. I mean, unfortunate for the patient, but it sounds like the treatment has gone well so far. Cool.
Yeah. So far, but still, I mean,
go ahead.
so how often do you see co-occurrence of tumors in your labs? It seems to be quite rare if you're not having a predisposition based on germline mutation, maybe in NF1 and the like.
We've seen quite a few, given we're a huge reference lab. And so when I'm looking through path reports for our different testing, sometimes I'll like, oh, this patient has, underlying CML. Like, let's just keep that in mind when we run our RNA panel. If we do see something on ABL1, that's probably another tumor, and we need to check the H&E to see if it's infiltrating, those kinds of things. Another thing that comes into play when we're dealing with multiple tumors sometimes is like quality metrics of the assay. And so the different quality, like from the analytical, like chemistry part of the assay, sometimes the algorithms have a hard time understanding when a patient has two different tumor populations, and so it could trigger like contamination or noise metrics more. And so that has become like a checkpoint for our laboratory to check the path report, make sure they haven't had a bone marrow transplant or have potential co-occurrence of a tumor. Sometimes even I can think of one instance where a client is actually using our test as like and we didn't know about it, as like a lineage type assay to see if like a second or third tumor from a patient was related to any others, which is important for like grading of the tumors. So, or yeah, stage and grade of different tumors. So, yeah, I'd say we've seen it quite a bit, but we're also a huge reference laboratory. I don't know, has anybody else had instances like this that they've encountered?
We recently had a BAL patient with history of CAL. We were able to identify 2 different genomes with different aberrations, and also with different allele frequency mutations. So that's how it can happen. I think we do have other patients too. We wanted to rule out if it's treatment related with versus primary tumor. I mean, primary in the heme malignancy is not the solid tumor. In this case, we're considering solid tumor with a heme malignancy.
Yeah. So I guess I kind of want to ask this. What if the BRAF and the KIT variants had been in the same tumor? How do we deal with therapy and recommendations in that instance?
That is a clinician question, because I would be, based on what discussions I've had, I would be inclined to think that given that imatinib is so effective for the KIT mutations in GIST, and that seems to be the presenting mass that's giving the patient problems, that you would at least try with imatinib, and then follow up if the BRAF if it didn't work, with maybe something like a trametinib or something like that. I don't know.
Sure. At least like from like the laboratory and reporting standpoint, you just give the clinician all the information. You say, okay, KIT is sensitive to imatinib and that family of therapeutics. BRAF, when seen in the same tumor, can cause primary resistance to imatinib. And then also the BRAF has therapeutic implications as well, although I believe they're off-label for GIST. I'd have to
Oh
check.
yeah, for sure off-label for GIST. Yeah, but I guess the one thing, looking at what we spit out in GIST, the one overlapping really difficult to tolerate therapy is regorafenib, which does target KIT and does target BRAF, like for these class 2 mutations, and it's approved in GIST. So it's on guideline for KIT. It's not, I mean, it's not a great inhibitor of BRAF, but looking at what overlaps in terms of the actual targets of the drugs, that's what pops out, and it's approved in GIST. So I don't know.
So potentially that would keep the BRAF at bay while targeting KIT, and then you can change course. I don't know. Yeah.
I mean, it wouldn't be, if I were to, it wouldn't be a first choice, I think. Well, again, not a clinician. And fortunately, there's no patient listening to me to say what I would do, but it would be my guess that they would probably try imatinib first and then maybe turn to regorafenib.
Manuela, did the clinician get the data about both of these mutations being detected in the GIST sample, and have to consider that information independent of the suspicion of CLL or the CLL sequencing results, or was it all pretty rapidly acquired information, one after the other?
No, it was multiple rounds of tumor board discussion. So we went back and verified that we had the BRAF mutation in the CLL sample. I mean, we were aware of the CLL and pathology already checked for the in the histology, but then again, from what you saw, it's really I would have said really very little to see anything in the panel sequencing. But if you look at the yield frequencies here, it's reasonable, detectable. Yeah, so it actually was multiple rounds of going back to do another diagnostic test in pathology. We have to say though that I mean the molecular pathology and pathology are always involved in the tumor board discussions, so they were aware of that and discussed there. I was just
Okay.
yeah. I mean, would be really interesting to see how one could take that into account earlier, maybe. I mean, I think in total it took a few months to get the full diagnosis and analysis done. Yeah, but then again,
Sure.
we have the question: what's the normal turnaround time in pathology and molecular pathology for NGS panels? That would be another interesting question. I mean, if you have to do follow-ups like this one, what are your turnaround times for an NGS panel, not whole exome?
Yeah, it's tricky, right? So every panel is different. Sometimes it depends on like, do you have extracted DNA or RNA left to run something and not have to go through an extraction process? And there's a lot of that, but also I think it's within our practice to like give a preliminary report if we do it under like a lab director discretion. So if we do find something that we're pretty sure is actionable and could like be treated right then and there, we can release a preliminary result and say that there are more data to come, but this may be of interest to you. In a case like this, I'm not sure how we would approach it, but yeah.
Yeah, so we usually have like from sample coming into pathology to like final report, we have turnaround times between 2 weeks and 4 weeks. I mean, we have rarely we have longer than that. So it was just out of curiosity, how long does it usually take in your lab?
Depends. I'd say like if we're running our large cancer panel, I take about a week to get results, all the way through the pipeline, because I think that right now our workflows aren't built to like give like significant priority, even when we do have priority cases. Like they still have to go on a batch and be sequenced and kind of sit in line and wait for analysis. Hopefully not long. Usually they're picked up pretty quickly. But yeah, about a week.
Okay, yeah. So that's quite a bit faster. I mean, 2 weeks is really like from first getting in the sample.
Yeah, I'd say like if we're getting a fresh sample that we still have to extract and like go through our tissue slide review and things, it's quite a bit more. But if we're reflexing and we have DNA, it's ready to go about a week.
Okay, yeah. I would second that. Okay, that sounds similar then to our cases.
Yeah.
Yeah.
Cool. I can't think of any other questions that I have, but thank you for bringing this forward. I hope that everybody enjoyed this new kind of format. I know that this was brought up as a suggestion for talking through like tricky cases and variants in real time and discussing as a group how we would manage cases like this. So if you have any feedback for us, feel free to send us an email But or if you have any cases or variants that you would like to bring to this forum, you can let us know too, and we'll bring it to this group in the next couple months probably. All right.
Okay.
Thank you.
Thanks everyone for joining, and have a great day.
Thanks, you
Discussion
too.
was great.
Bye.
Thanks a lot.
Yeah.
Thank you.